Hello everyone and welcome back to the channel. If you've been coding for a while, you know that errors are an inevitable part of the process. Today we're going to tackle error handling in Python. We'll look at how to gracefully handle errors and exceptions to make your programs more robust and user-friendly. So let's get started. So first up, we'll start with what is error handling. Error handling is a mechanism that allows you to catch and deal with errors and exceptions that occur during the execution of a program. This can help you avoid crashes and provide useful feedback. The basic building blocks of error handling in Python are the try and except blocks. Anything that is indented below the try or except are going to be part of those blocks. And if an error happens inside of the try block, it will then get cached by any sort of exception handling down below it. Here in this example, we tried dividing by 0, which would normally crash the program. However, the try block allows us to catch the error and print a user-friendly message instead. So if we go ahead and run this, you can see it says you can't divide by 0. And if we were to take this try except away and run the program, it would throw an error. And here we are using a very general exception that will catch any error exception that happens within the try block above. It's generally not a good practice to use just exception to catch all errors, but for this tutorial, I'm just informing you about it. Another thing to note is we don't have to include a specific exception to catch. So if we were to get rid of this exception variable right here, this is essentially doing the exact same thing by catching a very general exception. But if we want to be able to do something with this exception, we will need to include the exception that you're catching here. And we'll see later on how we can actually do something with the exception. So we'll go ahead and modify this to be a more specific error handle. So in this case, you can see from our last output that we had a 0 division error. And so that's the only thing that's happening inside this try block is dividing by 0, or the possibility of dividing by 0. So that's the specific error that we're going to catch. So if we go ahead and run this, it does catch it. It doesn't throw another 0 division error into the console. We can also get the error message from the exception that happened. We do this by adding as and then whatever we want a variable to be called. So in this case, I'm calling it exception. And then we can go ahead and print this exception. So whenever we go ahead and run this, we have the you can't divide by 0. And the specific error message that's coming back is the division by 0 message. This can be very useful when you have a very large code base and you want to know specifically what happened to cause the error. We can also catch multiple exceptions using multiple except blocks. So in this case, we have x is equal to int of our string, and we still have our exception of a 0 division error. But if we go ahead and run this, it ends up throwing another error, but this time it's a value error because it cannot convert this string to an integer. We can add this second except block with a value error to catch for this specific case. So whenever we go ahead and run this again, you can see it doesn't throw that value error in the console and just has whatever we printed inside of this value error except block. And you can stack as many exceptions as you need. We can also use the else block for more control. A lot of programmers don't know that you can use an else block in a try except case, although sometimes it's not really necessary. So in this case, we have a variable result is equal to 10 divided by 5. And if there are no errors, then this else block will go ahead and run. So whenever we go and run this, we can see that division was successful down in the console. The try except also has a finally block that will run no matter whether there was an exception or not. So here we added the finally keyword and we added the print this will always run. So whenever we go ahead and run this, we can see division was successful and this will always run. If we change this 5 into a 0 to raise the 0 division error, it will go ahead and say you can't divide by 0, meaning we got that error, but it still says this will always run, meaning it got to that finally block. And so in Python, you can raise exceptions to indicate that something exceptional or unexpected has happened that cannot be dealt by the normal program flow. Exceptions are raised when an error or other exception condition occurs in your program. Once raised, an exception will propagate up the call stack until it's caught by an exception handler. If not caught, the program will terminate. We can raise an exception using the raise keyword in Python. And then we can call the exception that we want to raise. So in this case, a 0 division error. And then we can actually specify a specific message that could be inside this exception that we're handling. So in this case, I'm adding the message wrong division, and then we're accepting the 0 division error as exception and printing that out. So if we go ahead and run this, we can see that it prints out wrong division. We can also create our own custom exception classes by inheriting from the exception class or any of its subclasses. So for example, we have a class custom error here inheriting from exception, and we're not having anything inside of it, so we're just passing. And then inside our try block, we're raising this custom error with our custom message of this is a custom error. and then we're catching that custom error as exception and printing it out. So whenever we go and run this, we can see this is a custom error. We can also catch and rethrow exceptions using the raise keyword without any arguments in an except block. So here we add the keyword raise in our except block, and whenever we go and run this, it does throw the custom error into our console and cause our program to stop running. Let's say we wanted to inherit this from a value error. We can go ahead and do that just by replacing exception with a value error. And Python does have several built-in exceptions like type error, index error, key error, and many more. You can look them up to see if there's a specific error you want to try catching. And well, that's all you really need to know for basic error handling. If you found this video helpful, don't forget to hit that like button and subscribe for more coding tutorials. If you have any questions or topics you'd like me to cover, leave them in a comment down below, and I'll see you in the next one.